We have some more doodle notes. This one is on standard form, so this is your new entry. It's still part of the same guided entry, but it's going to be its own page called standard form. So what exactly is standard form? Standard form is when we have an equation where the x and the y are on the same side. There's some important pieces to standard form, but really the basis of why we use it is we use standard form. It makes it very easy to pick out the X intercept and the Y-intercept. Okay, and I'm actually going to change this. I want to use two different colors here. I'm going to make this Y-intercept in red and the X-intercept in blue. I didn't really have to change this one. So Y-intercept, X-intercept. Okay, so what do the A, B, and the C mean? The X and the Y, those are just variables. Those aren't going to change. Just like in slope-intercept form for those doodle notes, I colored it in black. Those values do not change. It's always X, it's always Y. A, B, and C, those numbers are going to change based on the equation that you're using. But in general, the X-intercept, or this A, the value that's with X, that's going to be a positive integer. Okay, what that means is there's no fractions, there's no decimals, it's just a number, and it's positive. B, which is the number that's on Y, that is going to be just an integer. It doesn't have to be positive, could be negative, but it's not going to be a fraction, it's not going to be a decimal. Just like this one here, we have 3x, negative 4y. This isn't a fraction, this isn't a fraction, or it's not a decimal. C generally is also an integer. Okay, and it can be any number, again, based on the problem. So feel free to kind of doodle in these letters. However you feel, see fit. Since I'm doing the Y-intercept in red, I'll do my B. C kind of helps you find both intercepts, so I'll make it both red and blue. And now we're going to go over the steps to, why this is such a useful part of graphing. Now you remember from the video that the X-intercept occurs where the Y value is 0. And the Y-intercept occurs when X is 0. So we're going to use that to graph this equation right here. So we have 3 steps of doing that. The first one is to plug in 0 for the Y value, and that helps you find the X-intercept. And we're going to do that work right here. So we have this equation 3x minus 4y equals 12, and we're going to do step 1, plug in 0 for y, okay, and we're going to find the X-intercept. So we've got 3x minus 4y, but y is 0 now, equals 12. And what that does by putting 0 in for y is it completely gets rid of the term that has y. Right? 4 times 0 is 0, so we completely get rid of that, and we're left with 3x equals 12. we divide by 3, just like Unit 1, where we solved equations. The 3's cancel, and x equals 4. That means the x-intercept for this equation is positive 4. 1, 2, 3, 4. So there's my x-intercept. Now step 2, we're going to do the opposite. We're going to plug in 0 for the x value, and that's going to give us the y-intercept. And again, we'll do that right off to the side here. Same equation, we've got 3x minus 4y equals 12. But now I'm plugging in 0 for x. So it's 3 times 0 minus 4y equals 12. And what that does is, just like before, it completely gets rid of the term that has x. 3 times 0 is 0. And I'm left with negative 4y equals 12. Negative 4y equals 12. Divide by negative 4. These cancel, and y equals negative 3. That means my y-intercept occurs at negative 3. And my very last step here is to connect these 2 points. I don't have my ruler again, so I'll just use my book, and I'll make a nice straight edge. Connecting those lines, making an arrow because I know that this line never stops, and that's it. That's all there is to graphing to standard form. So it's easier than taking this equation and putting it into slope-intercept form, which you could do. The slope would end up being up 3 over 4. The y-intercept would be negative 3. So the equation of that line in slope-intercept form would look like y equals 3/4 x minus 3. But we don't have to go through the algebra process of subtracting 3x from both sides and dividing by 4. We can go through this step here. And this is going to be really beneficial if you have a slope that's like 27/12, or 37/4, something like that. Sometimes in order to use this method we have to first write things in standard form, and that just means making sure that x and y are on one side and that we have x as a positive integer. So recall standard form means that a is a positive integer, not x, sorry. A is a positive integer, b is an integer, c is an integer. So we shouldn't have any fractions. And that's what we're going to do for these two here. For this one, recognize that 3x is on the right, 2y is on the left of the equal sign, so we've got some rearranging to do. One thing we can do is we can subtract 3x from both sides. Now I can't take 3x away from y, so it leaves me with negative 3x. That's a positive 2y, so plus 2y equals negative 18. Now, according to my standard form, this has to be a positive integer. Negative 3 is not a positive integer. So I need to make this positive, and I do that by multiplying everything by negative 1. So back in Unit 1, we learned that I can keep an equation true if what I do to one side, I do to both sides. So if I multiply this by -1, I have to multiply this by -1. And basically what that does is that changes every sign in every term. So this becomes a positive 3x. This becomes a negative 2y. This becomes a positive 18. So that's the standard form of this one. And then to graph and find the intercepts, you would use this process here. Right? These 3 steps, which look like this. Now this second one here is a little bit more tricky. We still want to get the x and the y on the same side, but we've got some extra terms to move around. So I'm going to start with subtracting 6x from both sides. And that gives me negative 6x plus y minus 4 equals positive 2. Now, I have to move this 4 over here, so I'm going to add 4 to both sides. And I get negative 6x plus y equals 6. And again, this term can't be negative, so I have to change the sign on every single term by multiplying by -1. Okay, for everything, which gives me a positive 6x minus y equals negative 6. And I would go through the process again of using those 3 steps to find my intercepts and then graph it. If you flip this doodle note over, you'll find a really nice quick way to find the intercepts, and it's called the cover-up method. And it's actually really cool and makes things really easy. In this one, they're covering up with the whole hand. You can actually just cover up with your pencil, makes it easier. Okay, but this is how the cover-up method works. If you want to find the y-intercept, say in this equation here, 6x minus 2y equals 21, you're going to completely cover up the term with y with your hand. Because in order to do those steps, when we find the x-intercept, we substitute y with 0, and the whole term cancels, always. So the whole y term completely cancels out. So we cover that up, and we get 6x, this is covered up, equals 21. We divide both sides by 6, and x equals 3.5. So it's a super quick, super easy way to find the x-intercept, which makes standard form really nice. You simply take your pencil, you cover up the term that has y, and you have 6x equals 21, and it's like a one-step equation. So you don't have to go through this whole process of substituting in 0, getting rid of the term, right, x equals 4. You can just cover it up completely. Right? 3x equals 12. Cover this up. 3x equals 12. So it's a nice, really quick method of finding the intercepts here. Same thing works with the y-intercept. To find the y-intercept, we completely cover up the term with x, and we can do that because when x is 0, the whole x term disappears. So we cover up the 6x in this one. We have negative 2y equals 21. Divide by negative 2. Y equals negative 10.5. So it's a really, really fast, really quick method to defining those X and Y intercepts. And once you have them, you can just quickly plot those points, connect the dots through them, make a line, and there you go. So what you're going to do is these 3 questions for practice with standard form. And once you're done with this, you'll check these 3 problems with your teacher. This one's definitely going to be a difficult one. You see you have some distribution here. This one, really similar to ones on the front side of this page where you just get X and Y on the same side. You may have to multiply by -1. But once you're done with these 3 problems, you'll show them to your teacher and then put this into your book. And so pause the video now, and I'd like you to work on these 3 problems. We just completed this entry on X and Y intercepts in this guided entry webpage. So you're going to turn it over, and this is going to be our standard form. Okay, standard form. So we're going to write that entry right up here. Standard form. And you'll see that this is 2-sided when you cut this out. So what we're going to do is we're going to kind of make a page within a page. Just like with slope-intercept form, you're going to take a piece of tape and you're going to just kind of tape this side of the page in so that you can flip it over and still see this right here. Now, we did do some work on the margin of that page where we found the X-intercept and the Y-intercept for this graph here. You can put this in your book right here if you want, so you can kind of see the work that goes with it. You could also put a piece of tape right on top here, and you'd be able to kind of flip that up if you wanted to. I think I'm probably just going to tape it right here or glue it in, and that way I can kind of see the work right away. And that's it for this entry. Move on to the practice worksheet 4.5 that was part of the packet for this guided entry.